Hello everyone, welcome back to my channel. In this lecture, I am going to discuss integration by parts. Integration, that is your integration of product of two functions. I am Dr. Bharat Kesari Swai, Department of Mathematics, Agarpada College, Odisha. So what is the theory of this integration of by parts? So it is used to evaluate the integral of product of two functions. When it is of the form, that means your integrand is of the form first into second, that means integration of f and g into dx. That means product of two functions. There are two functions f and g are there, and we have to integrate it. Then this by parts rule is applied as follows. Come to the next slide. There will be the rule of this integration by parts. So what is the rule? That means the formula is what? What is the formula? First into integral of second, then integral of derivative of first, integral of second. That means in formula we can write like this: first into integration of second minus whole integration of derivative of first, integration of second. And to apply this rule, we have to choose what is your first function and what is your second function. For this, we can apply this is the standard notation. That means if there are two functions u and v, then u v dx, integration of u v dx. Suppose u is the first function and v is the second function, then u is into integration of v minus derivative of u, integration of v, whole integration. Is not it? Whole integration. So this is the formula for by parts. But before this application of this formula, we have to choose what is your first function and what is your second function. So to choose first and second function, we can apply this Eilert rule. What is Eilert rule? This is the correct sequence. Means in this sequence we have to choose first and second function. Which comes first, that will be first function, and which comes second, that will be second function. And what is Eilert? I is for inverse trigonometric function like tan inverse x, sin inverse x, cos inverse x, like this. And what is L? L is your logarithmic function. A is for algebraic functions like x square, 1 plus x square, like this. And T is for trigonometric functions and like sin x and cos x. And E is for exponential function like e to the power x, a to the power x, like this. So in this order we have to choose first and second function. Which comes first? Suppose there are two functions x into e to the power x. Okay, so x in the e to the power x. So x is your algebraic function, e to the power x is your exponential function. So in this sequence Eilert, a comes first, then exponential comes. Therefore a is your first function and exponential will be the second function. Okay, so like this we have to choose first and second function in this order. Okay, therefore, and after getting this first and second function, after choosing first and second function, we can apply the formula of by parts. Come to the steps of integration of by parts. That is, already I have told that identify the product of two functions. Identify the product of two functions first. Then choose the first function using Eilert rule. Then differentiate the first function integrate the second function and apply the formula and simplify. So first we have to choose first and second function, then differentiate first function, integrate second function and apply the formula. What is the formula? First into integration of second minus derivative of first into integration of second, its whole integration. So this is the formula. Come to the problem. Just remember these things, not more, only remembering this formula and highlight, that means order of the function, how to choose first and second function, we can do the problems like this. Suppose this is the integration of x e to the power x dx, x into e to the power dx. So see here, this is a product of two functions, one is x, another is e to the power x. One is x, another is e to the power x. So here we have to choose first and second function. So from ilet, okay, so a is algebraic function, that means a, and exponential means this is your exponential function. So what comes first? A. So this is your first function, then exponential is second function. So choose x as first function, exponential is as second function. This is your first function, this is your second function. So from our formula of by parts, first into integration of second. So x is your first function, exponential e to the power x is your second function. So x into e to the power x, integration of e to the power x minus derivative of first. So derivative of first means derivative of x. So that is your 1. Derivative of x is 1. Then integration of second. Is not it? What is the formula? First mane x, then integration of second, then minus derivative of first, that means dy dx of x, into integration of second, that means integration of e to the power x, then whole integration. This is the formula. So that will be equal to x, then integration of e to the power x means only e to the power x. Okay, what will be the result? What will be the result? So this is your x, this is your x, then integration of e to the power x means only e to the power x, minus derivative of x means 1, then integration of again e to the power x means only e to the power x, then whole integration. So that is equal to x e to the power x minus again integration of e to the power x dx, that is your e to the power x, plus some integration constant c. So this is the result, and if you take from this e to the power x common, then your it will be x minus 1 plus c. So this is the result. Okay, so this is very simple question. So main thing is we have to choose what is your first function and second function, then remember the formula. First into integration of second minus derivative of first, integration of second, whole integration. This is the formula. Okay, come to the next example. Problem number 2, same thing. Question is x into integration of sin x. So according to our rule of ilet, that what is your first and second function? Ilet, what is your first and second function? So then x is your algebraic, sin x is your trigonometric. Algebraic, then it is trigonometric. So first algebraic comes. So x is your first function, this is your first function, and sin x is your second function. X is your first function, then sin x is your second function. So then according to the rule, integrate. So first into means x, first into integration of second. So integration of sin x means minus cos x, then minus derivative of first, so derivative of x, that means 1, then integration of second, then that is your minus cos x, then whole integration. So that will be your x into minus cos x then minus, and here is also minus, so minus minus plus. So again integration of cos x means your sin x plus c. So this is the result. Okay, so this is how we can apply by parts rule to solve this type of integration. Come to the next problem. Problem number 3. It is very important question for your exam actually. So here see integration of tan inverse x. Integration of tan inverse x. So you can note that we have already told before that this is integration of by parts rule is applied for product of two function. Integration of product of two function, but here only one function is there, only tan inverse x. So to use by parts here, we have to take 1 as second function, because tan inverse x can be written as tan inverse x into 1 dx. Is not it? So that because it is the rule for product of two function, we have to take two functions. So only tan inverse x is there, but we can multiply 1 with this. So this can be written as integration of tan inverse x into 1. Now you can check according to our rule islet. According to our rule islet. So what is your first and second function? Because 1 is your algebraic function. 1 is the algebraic function. Then this is your inverse trigonometric function. This is your inverse trigonometric function. Therefore, first come what? Your inverse comes first. Inverse trigonometric function. Then algebraic. So your tan inverse x is your first function and 1 is your second function. Therefore, tan inverse x is your first function and 1 is your second function. Now use your by parts formula. First into integration of second. So first means your tan inverse x. Then integration of second means integration of 1. That means only dx. Then derivative of first. So derivative of tan inverse x means 1 by 1 plus x square. Then integration of second. Integration of 1 means x. Integration of 1 means x. Then its integration. So that is equal to x into tan inverse x, because integration of dx means x. So x into tan inverse x minus integration of x dx by 1 plus x square. X dx by 1 plus x square. Now see here, this is already solved, but here this is integration. So this integration can be solved by using your substitution method. Using your substitution method. How? Just put 1 plus x square is equal to u. So if I take 1 plus x square is equal to u, then your 2x dx will be du. And what is your x dx? X dx will be du by 2. Du by 2. So the integral will be reduced to integration of what? Du by 2u. Du by 2u. So 1 by 2 is constant. Then your result will be 1 by 2 ln u. 1 by 2 ln u. And the value of u is what? Value of u is 1 plus x square. Therefore, your result will be half ln 1 plus x square. Then plus some integration constant c. So this is the result of this problem. Okay, this is how we can integrate tan inverse x with respect to x. Okay, come to another important example. It is very popular example, that integration of ln x, and it is also important for the exam. Integration of ln x dx. So same process. Here we can apply your by parts rule after multiplying 1, because ln x is only function is there. Ln x is only function, but we have to write like this: ln x into 1 into dx, so that we can apply by parts formula. Now this is a product of two function, and from your Eilert rule, what comes first? What comes first? First logarithm, then algebraic. This is your logarithmic function, this is your algebraic function. So your ln x is your first function, ln x is your first function, and 1 is your second function. 1 is your second function. Ln x is your first function. So according to our rule, first into integration of second. So ln x into integration of 1 dx. Ln x into integration of 1 dx minus derivative of ln x, that means your 1 by x. Then integration of 1 mane x. Then whole integration. Now this will be equal to ln x into integration of 1 dx, that means your x, minus 1 by x, x cancel, so integration of dx means only x, plus c. So the result is what? X ln x minus x plus c. This is the result. X ln x minus x plus c. And note that it is very, very important for the exam. Okay, now come to the another problem, that is x square e to the power x dx. So now here there are two functions, x square and another is e to the power x square and another is e to the power x. So since according to Eilert rule, what is your first function? X square is your algebraic, and e to the power x is your exponential. So what comes first? First algebraic, then exponential. So first algebraic, then exponential. So this is your first function, this is your second function. So use the rule now. So what is the rule? First into integration of second. So first, then integration of second means integration of e to the power x is e to the power x. Then minus derivative of first, then integration of second, whole integration. So first into e to the power x integration means x square into e to the power x minus derivative of first, that means integration of derivative of x square. So it is 2x, then integration of e to the power x, then e to the power x. Now we have to integrate this. X square e to the power x minus integration of 2x e to the power x dx. So to integrate this is the rule. Again we have to use, because again we got what? Again we got this type of integral. X is there, that means 2x is there, and e to the power x is also there, and 2x is your algebraic function, this is your exponential function. So according to Eilert, so first comes your algebraic function. So again check this as first function, take this as second function. Again use the rule. That's why we are writing here second application of integration of by parts. So two times we have to apply the by parts rule. So using by parts rule, we can again integrate this. Therefore 2x into integration of this, then derivative of 2x, integration of e to the power x, whole integration. So 2x e to the power x minus derivative of 2x means only 2, then integration of e to the power x means into us. Now it is done. That is 2x e to the power x minus integration of 2 e to the power x means minus 2 e to the power x. Okay, so the final result is what? Put all these values here. So final result is, this is the final result, is not it? So this is how we have to apply our by parts rule. So when we need your by parts rule 2 times, we can apply 2 times. Next, another example is problem number 6, that is your integration of x square sin x dx. So according to Eilert rule, what is your first and second function? Choose yourself. Choose yourself. Everyone, choose yourself. What is your first function and what is your second function? So according to rule, first comes your algebraic, because x square is algebraic and sin x is your trigonometric. Therefore, algebraic will be first function, that means x square is first, second is your trigonometric function. Clear? And then apply the rule, as usual rule, because x square into first into integration of second, then derivative of x square, integration of sin x. So minus integration of sin x means minus cos x, so it is minus x square cos x, and derivative of x square is 2x, integration of sin x is, we know that, minus cos x. So therefore minus cos x, and again minus is there, therefore it is plus 2x cos x dx. Now again, to integrate this, we have to apply by parts formula. Here. Integration of 2x dx. Same thing, this is your algebraic first function and this is your trigonometric second function. Again, use your by parts rule, first into integration of cos x, then derivative of 2x, integration of cos x. So therefore it is integration of cos x means your sin x, so 2x sin x minus derivative of 2x sin x, derivative of 2x is 2 only, and integration of cos x is sin x, so integration of 2 sin x. Now this is your integration of sin x minus cos x, so minus plus, so the final result means your result of integration of 2x cos x dx is this, and put it back in the original result. So this will be our final result. Integration of x square sin x dx is equal to minus x square cos x plus 2x sin x plus 2 cos x plus c. Clear? Come to another example. This is also important. That integration of ln x whole square, because ln x whole square is one of the function, and to use by parts, your another function should be there, so we take this as 1, because we can write this as ln x square into 1 into dx. Therefore choose, because from Eilert we know that first logarithm, then algebraic. So this is your first function and 1 is your second function. So applying the by parts formula, so first into integration of second, that means integration of 1 is x, so x ln x square minus derivative of first, that means derivative of ln x whole square, so 2 ln x into 1 by x, because derivative of ln x means d by e. Derivative of ln x means ln x whole square. Okay, so dy dx of ln x whole square. So therefore it is 2 ln x into, again derivative of ln x means it is 1 by x. Is not it? So 2 ln x by x. So therefore it is ln x whole square dx minus 2 ln x, and integration of 1 means again x, and x cancels, only 2 ln x dx. Integration of 2 ln x dx. Now for this integration, again we can use by parts rule. Here. How? So integration of ln x. integration of ln x dx is your, choose ln x as first function. Already we have done in the previous problem, that is integration of ln x. Take 1 as second function and as usual formula, and we will get x ln x minus x. The result of ln x dx is your x ln x minus x. So put this value in the previous and we will get the final answer, that is, this is your final answer. Okay. Integration of ln x square ln x whole square equal to x ln x whole square minus 2x ln x plus 2x plus c. Right. So this is how we can apply your by parts rule to integrate product of two functions. This is another important example, x into tan inverse x. X into tan inverse x. From this I let just choose your first and second function. Check here what is your tan inverse x, means your inverse trigonometric function. X is your algebraic function. X is your algebraic function. So inverse trigonometric comes first. So this is your first function and x is your second function, and then use your rule. First into integration of x dx, then derivative of tan inverse x means 1 by 1 plus x square, then integration of x means x square by 2, and after solving it will be x square by 2 tan inverse x, because integration of x is x square by 2 into tan inverse x minus 1 by 2, and the integration of x square 1 plus x square dx, x square by 1 plus x square whole into dx. Now to integrate this, how to integrate this? Come to next example, next slide. You can check here. To integrate this, just add plus 1 and minus 1. Just add plus 1 and minus 1. Is not it? Just check here. 1 minus, because we can take it as x square plus 1 minus 1 divided by 1 plus x square. Then we can separate it as we can separate it as 1 plus x square by 1 plus x square and minus 1 by 1 plus x square, and this value is 1 and this is your 1 by 1 plus x square, is not it? So therefore this is x square by 1 plus x square is equal to 1 minus 1 by 1 plus x square. Now to integrate this different both side, just integrate on both side. What we will get? Integration of 1 means x and integration of 1 plus x square means tan inverse x, is not it? Integration of 1 means, because integration of, we have to integrate x square by 1 plus x square, is not it, into dx. So therefore just integrate this, integration of 1 minus integration of tan inverse x, integration of 1 by 1 plus x square into dx, and this is your 1 into dx, and this is your x minus integration of 1 by 1 plus x square means tan inverse x. Okay, so this is how we can integrate your x square by 1 plus x square dx. And this is the result of this, and your final answer for this problem is like this. Final answer of the problem is like this: x square by 2 into tan inverse x minus half into x minus tan inverse x plus c. Okay, so it is one of the important rule for the integration, and it can be applied in different problems like we have discussed. Another example is here, problem number 9. Integration of x square minus x square. Integration of a square minus x square into dx. Okay, so to apply here your y parts, same thing, just multiply 1 here, and choose this as first function, this is our second function. Then use your by parts rule. First into integration of second, here first into integration of second, then derivative of first into integration of second. So x is your second function, so 1 is your second function, so integration of 1 is 1 x. So minus derivative of first, so derivative of a square minus x square is this. Then integration of second means again x, then whole integration, and the result will be x into a square minus x square root over plus, because minus is there, so minus minus plus, integration of x square minus divided by root over of a square minus x square. And this, for this integration, come to the next slide. Okay, so to integrate this, just simplify like this. X square by x square, just to write x square means write x square as a square minus x square minus x square. You can write like this, is not it? So for this integration and for the numerator we can write like this. Then separate the integration, separate the values. A square minus this, one is a square by this, and another is a square minus x square by this. Okay, so it will be a square into integration of dx by root over of a square minus x square, and another is integration of root over of a square minus x square root over of a square minus x square. Okay, and we know that how to integrate this, because already you have so come to the next slide. If I substitute back all these values, then the result will be like this. Root over of a square minus x square dx, all these values, just check here. Put all these values from this a square minus x square dx, here is also root over of a square minus x square dx. Then take this term to the left hand side, so it will be 2 into this and x into a square minus x square, and integration of this is, we know that sine inverse x by a. This is your sine inverse x by a, and the final result will be just divided 2, because we need this integration, so just divide 2 on right hand side, so it will be x by 2 into root over of a square minus x square plus a square by 2 sine inverse x by a plus c. Okay, so these are some standard formula we have to remember. Using this by parts we can derive all these formulas. First is root over of integration of root over of a square minus x square. This is in the problem number 9 we have derived this. Then integration of dx by root over of a square minus x square is sine inverse x by a plus c. Then root over of a square x square minus a square dx, already same in the same process. Okay, same in the same process we can derive, and integration of dx by x square minus a square will be ln x plus root over of x square minus a square plus c. Then integration of a square plus x square dx will be x square by 2 x by 2 root over of a square plus x square plus a square by 2 ln x plus root over of a square plus x square plus c. And then integration of dx by a square plus x square root over, it will be ln x plus. So all this formula we can derive using our by parts rule. Already we have done these two, and remaining 3 or 4 we can derive easily using your by parts rule. Okay, and these results can be used directly as a formula. Okay, so thank you everyone. So try to do different types of problems using by parts from your book, from your other exercises, so that you will be very clear. And if you will face any doubt, then you can ask me, and I will try to all these I will try to clear all these doubts. So thank you again, everyone. Thank you.